This lesson is on graphing linear relations. The goal for this lesson is to, well, obviously, be able to graph linear relations. So quickly, just to get your brain thinking a bit about patterns, let's do this minds on. So finish the following table. So you're going to fill in those missing blanks. Why don't you stop the video now and give that a try? Did you stop it? Have you done it yet? Okay, here are my answers. So I wrote down the answers that I got, and you'll notice 70, 100, and 130. Now, how did you figure that out? Well, we know that we start with 10, and then we went up to 40, and so the difference between that is 30. If we know that we're adding 30 each hour, then we're going to add 30 to get to 70, 30 to get to 100, and 30 to get to 130. Notice that it goes up by the same amount each time. So every time we add an hour, we add $30. So I'm sure that you've had lots of experience looking at tables and graphs over the years. Often when we're looking at tables or graphs, we're comparing the relationship between two or more variables. This relationship can either take the form of a linear relation or a nonlinear relation. Now, they mean two different things. Linear relations are straight lines. So when we graph them, they can be joined by a line and they'll be straight. The other option we have is nonlinear. So it's in the name. Linear is a line right there. Nonlinear is no line. So when it's graphed, it's not a straight line. It takes the form of a curved line, usually. So now let's get to graphing some linear relations. Here is our first equation. This equation represents a line. Now, we don't know what this line looks like or where it will fall on our Cartesian plane, but we know that it will be a line of some sort. In order to figure out where and what the line looks like, we're going to use a table of values in order to find different coordinates within that line. So you'll notice that we already have a table set up here, and there are already some values within it. We have numbers ranging from -2 to 2. These are usually the numbers that we use. It does change from time to time, but usually we go with these numbers because they're the simplest ones to work with. You should notice that we have both positive numbers as well as negative numbers. It's often important to see what's going on both sides of our Cartesian plane. So that's why we have a range of both. Okay, now to talk about how we actually find the coordinates along our equation. How we do that is by taking the x value and substituting it into our x variable. I'm going to rewrite the equation, and I like to start with 0 because in this case it's super easy. All I'm going to do is I'm going to substitute my x value inside, and remember I'm using 0 as my x value. So 3 times 0 is obviously 0. So my y value of this particular coordinate is 0. I'm going to do this again for each and every single y value. So we have a total of 5 y values. I've already done one. I'm going to do the next one. It doesn't matter what order you do them in, but the next one I'm going to do is when x is equal to 2. So I'm going to rewrite the equation again, so 3x. And remember, I said I'm going to do when x is equal to 2. So if x is equal to 2, then anytime I see an x, I'm going to replace it with the number 2. This gives me 6 because 3 times 2 is 6. And I'm just going to put that into my table. Okay, I'm going to do one last one with you, and I'm going to solve for y when x is equal to negative 2. So 3 and x is equal to negative 2. Don't forget to write your y down. So 3 times negative 2 is negative 6. Okay, now you pause the video and solve for when x is equal to negative 1 and 1. Pause the video, figure that out. Okay, I got negative 3 and 3. Did you get the same answers? So, we've filled out our table of values, but now what we have to do is actually graph the equation. So I'm going to go ahead and plot those coordinates. Remember, our x and y gives us 5 different sets of coordinates. So I'm going to go and plot each one. We have our first point, 0, 0, which lies on the origin 0, 0. Our second point is at x value 1, y value 3. And we can do the opposite of that, which is x value negative 1, y value negative 3, x value negative 2, and y value negative 6. And our final point is x value 2, y value 6. So we've drawn our points. Now we need to draw a connecting line between these points. Because remember, we're drawing a linear relationship here. It's really important that you put arrows on your line. These arrows indicate that the line could potentially go on forever and ever and ever. And because we don't know anything about this set of values or this set of information, we say that it goes on forever and ever and ever. The other thing that's important to know is that you must draw or write your equation beside your line. And this is just us labeling this line as this equation. Okay, let's talk about our next equation. So I'm going to do the exact same thing as before. I'm going to rewrite the equation for x plus 1, and I'm going to substitute my x values in for my x variable. Like I said, 0 is super easy. I like to start with 0. 4 times 0 is 0, plus 1 results in 1. So y is equal to 1. That's our first coordinate. Our next coordinate is y is equal to 4x plus 1, and this one I'm going to do it when x is equal to 1. So I'm going to substitute 1 in anytime I see an x, and so 4 times 1 is 4, plus 1 is 5. So my y coordinate is 5. Okay, so here's the time where you stop the video and try solving the next coordinates on your own. Okay, did you do it? Here's my answers. Did you get the same answers as me? So, the problem is telling us to graph it. So I'm going to go ahead and graph all of those coordinates. Okay, so I've plotted my points, and now I'm going to draw my line between those points. And don't forget to include your arrows and your equation, naming your line. Notice that it grows by 4 each time. It grows by the same amount each time. This means it's linear. Okay, I want you to try this example entirely on your own. So pause the video now, try it on your own, and when you're done, compare your answers with mine. Okay, here are my answers. Did you get the same thing? If you haven't already done it, pause the video and draw your graph now. Okay, I've done my graph. Notice I've included my arrows on my line as well as my labeled line with my equation. Notice again that we have a consistent difference in the values of our y-coordinates. It goes down by 2 each time. So it's always a change of 2 in this equation. Okay, let's move on to our last problem set. In this example, Marcus charges his friends to ride his bike according to the following graph. A. Fill in the following table. So we don't have an equation here. What we do have, however, is a graph. So if we read the graph, we can fill in the table. Let's find distance of 0. So our distance is on our x-axis, and 0 will be right here. At distance 0, it looks like our cost is $2.50. So I'm going to write in $2.50, 2.5. At a distance of 1, that's our x-coordinate, we need to find our y-coordinate, or the cost. So our y-coordinate, if we go up, follow 1, and then we track over to our y-axis, we see a value of 3. So we can repeat this process for each value. If we go over to 2, we track up and then over to 3.5. And finally, for our distance of 3 kilometers, we have a value of 4 for dollars. Here's Marcus again, still charging his friends to ride his bike. Not very generous in my opinion. Pretty crafty though. How much would it cost to ride Marcus's bike for 11 kilometers? Okay, so we need to find the cost at 11 kilometers. Notice we only have data for these first 3 points, but because it's a linear relation, we can extend that line out to find for however many kilometers we need to. In this case, we're only looking for 11. So let's find 11, and same as before, we're going to track up and over onto our y value. So at 11 kilometers, our cost is $8. Okay, so I wrote down our final answer as it would cost $8 to ride the bike for 11 kilometers. In this final scenario, it says, how far would you have gone if it cost $6 to ride Marcus's bike there? So, in the past scenario, we were looking at distance, and so we had 11 kilometers, and we wanted to find the cost. This time we're working a bit backwards, where we first have to find the cost of $6, because we know that that's how much we had to pay. So we track over and down to find the x value, which is 7. And so our final answer is 7. Being able to read graphs is really important, yes, for math and science and all that, but just generally in order to be a person who is literate. So that just means you're able to read and understand and take in information, and then you can process and use that. So yeah, generally really important skill. And now it's time for you to do some homework. So check out the hub to find out what that homework is.